From in the beginning anyway, from your biology class. You finding that? Anybody find out anything interesting about their favorite foods that you were supposed to do this weekend?
Realize how much meat I'm actually eating.
You're eating a lot of meat. No, but remember I told you I want you to go online and look up the nutrition facts of your favorite delicious go out to eat meal. Did anybody do it? Yes, dear.
I did the animal cookies that are frosted, like pink and white, and they have the little like jimmies on them.
Mm-hmm.
And I could probably sit there and eat half the bag.
Oh yeah, at least, right?
And the bag is 13 ounces, and a serving size is 8 cookies.
And how many servings do you think you pound down when you eat your cookies?
Probably 2 or 3.
At least, right?
And so now I know I should go for the cookies that have all their legs and their heads.
Get the biggest bang for her buck. Okay. Ah, a woman after my own heart. It's like when I get almonds or something and I count out 28 of them. I want to make sure I get the biggest ones. Is that what I'm supposed to be doing though? No. Because I'm probably getting more than I should because I'm eating all the biggest ones, right? Nobody looked at any other food?
I forgot, but I knew what food I was going to look up.
What were you going to look up?
I always, whenever we go out, I always get some type of red meat. So, chicken.
Is that because you usually don't?
I was saying even at home, I could pour red meat and chicken or
All right, I didn't want to do this, but all right, I'm going to have to do it. Oh, shoot. I'm not able to get online because this room is possessed. Drive me crazy. All right, we can do it on this one. I'm going to do it and we won't see it, but we'll talk about it. What do you want to look up? Who likes to go to Panera?
mac and cheese all the time.
Mac and cheese?
They have the best mac and cheese there.
All right, let's go look up Panera. Okay, and a lot of, there's so many different restaurants, especially chain restaurants, that have all of their dietary information up online. Did you know that? Pretty much all of them. I think it's something that is kind of required these days, which is good. Yeah. All right, so pick something. Oh, you said mac and cheese, right? Pastas? Oh, come on. Actually, I'm going to put the PC up there so we can see. Pastas. What do we got? Anything? Oh, here we go. Mac and cheese. Of course, I'm blind as a bat. 980? Where are we? So a small. Who gets a small when they go? You get the small? Good. 490 calories. Okay? How many fats? 30 grams. Right? And that's only 1 cup. When you get the small, guess what? I'm guessing they're probably giving you a little bit more than 1 cup. What do you think? You think it's 1 cup?
I'd like to think.
You'd like to think? Okay, I'm having a hard time seeing, so give me, what's this? Saturated fat, 13 grams. Who's that? Cholesterol, 65 grams. Sodium, 1,240 milligrams. All right. What's that? Carbs, 37. Fiber, 1. Woo! Sugars, 7. Protein, 17.
Isn't that sodium like the max you're supposed to get each day? Isn't that what it said in the book?
2,000.
That's almost half.
Yep, over half in just your mac and cheese, right? Just your 1 cup of mac and cheese. What else? Anybody else like Panera? The salads. We go there for the salads because the salads are good for us, right? And the salads are like diet food, right? Let's see, the chicken Caesar salad. That's one that people seem to think are good for them, right? What Panera has decided to do now because of this is offer half portions. So let's say the regular full portion, whole salad, 400 and whatever. How much fat? 24, 25, I can't even see that number. All right, saturated fat, 7. Sodium, 660. That's not as bad as it used to be. It used to be a lot worse. I'm guessing, because it says chicken Caesar.
That's not counting the dressings, though.
Dressings. Let's go look at the dressing. Because that's usually the downfall of the salad, yes? You go and get the salad, and then you, like, I have a sister-in-law that uses like half a bottle of salad dressing on her salad. And she thinks she's being very healthy because she's eating the salad. But 3 tablespoons of a vinaigrette dressing, 110 calories, 9 grams of fat. Let's go down to a nice, yummy, creamy one. Oh, Greek herb vinaigrette, 220 calories for 3 tablespoons. Do you ever measure out 3 tablespoons of dressing? Yeah. You know the ladle when you put dressing on your salad? And that's probably 2.5 to 3 tablespoons. How many times do you put the ladle on your salad? They have some low-fat options. They're putting some better stuff on their menu. But before you go out to eat, you should check out the menu. Yes? Some places actually are starting to do this now. What other delicious foods do we like to eat? Chinese? That would be a tough one. Olive Garden? Oh, the Alfredo. Yeah, let's look that up. Let's go see. The what? Classic lasagna. Okay, let's see. Let's see what we're going to have. So we're going to go in for the Alfredo, right? Is that under appetizers? Is that fish and seafood? Yeah, like a little side of the Alfredo, right? So chicken fingers, 330 calories. Where is it? Is it there? Oh, there it is. Dipping sauces. And how much? Probably not a whole heck of a lot. Didn't give us a number. 460 calories for your Alfredo sauce. 43 grams of what? Fat. And that's you haven't even started the meal yet. You're just dipping some Alfredo. What about the breadsticks? They should be in here. Oh, there it is. 1 breadstick. How many do you eat when you go? It's unlimited, goodness gracious. You're not just going to eat 1. So you say you have 3 breadsticks in the Alfredo. You haven't even eaten yet. And you already have what? Yeah, over 1,000 calories. Never mind 1,000 calories. Look at the sodium. So 3 breadsticks. Look at the Alfredo. 370 milligrams of sodium in just one. So multiply that by 3 plus your dipping sauce. And that's not even your meal. And that's only one meal. That's not like the whole day's worth of food. Right? Do you wonder why we see all of those red states on our the United States map? Because we have places like this. Yummy. Taste of Italy. Well, let's see what we're feeding the kids. There we go. What are we feeding the kids? The kid portions are probably what we should be eating, right? But who wants to go to a restaurant and just get a small portion? If I'm going to go to a restaurant, it's got to be a big, huge plate, right? I mean, what good is a restaurant if the plate's not overflowing all of the sides with food?
I looked at Domino's because, every couple of weeks I usually get Domino's.
You like the Domino's?
I think it's 250 calories for one slice of FBD pizza. And I mean, who eats one slice of pizza? And then I get cinnamon sticks. And cinnamon sticks for just one little slice of cinnamon stick is none of it has the sauce.
Yeah, just the stick. You got to put the white stuff on it, right? So when we eat out, what do they put in our foods to make them taste good? They put fat and they put salt, because that's going to make them what? That's going to make them tasty, and it's going to make you want to come back and buy more of their product, right? So be careful when you go out to eat. And it's okay to go out to eat, right? But plan for it. Like if you want those little animal crackers with the sprinkles. It's so funny you say that, because my kids were like, thought I was God when I brought those home. It's the animal crackers with the sprinkles. But, it's okay to have those things, but keep in mind that if you're having trouble, if you're gaining weight and you don't know why, that's why, right? Because it seems like it's little tiny animals. How could they possibly be harmful to me? Right? All right, are we really what we eat? So, why do we eat? Because we're hungry and animal crackers taste delicious and Alfredo is wonderful and it makes us happy, right? But really why we need to eat is for what? We need the building blocks to build our bodies, and we need energy. We need that energy for heat and body temperature regulation, and for the building blocks for the cells that we need to build us. Now, is there anyone in this class that there's 2 people? Live to eat and eat to live. Is there any eat to livers in this class? You eat because you know you have to eat. And you just eat, and there's nothing too exciting about it. You just eat. Is that you? Now, everybody else I noticed didn't raise their hand, because they're in the other category, right? Why do you eat? Because it's awesome, it's exciting, it's giving you something besides just the building blocks. That's not how everybody looks at food. So food, we have to draw ourselves to it so that we can eat it. And we have other senses, we're built that way as humans, to draw us to food. Our sense of smell, our sense of taste, sight. If I took some brown, gloppy stuff with like little worm-like structures sticking out of it and I plopped it on your plate, would you eat it?
You mean the cheese they eat in Sardinia?
Yeah, the maggot cheese. Would you eat it? Why?
So you can see it.
Because it doesn't look so good. It might taste really good, but that's part of getting us to food too. So our sense of sight, our sense of smell. Some people have problems with the textures of things. We have any texture issues? Yeah, okay, texture people. It's squiggly, it's smushy, it's no, can't do it because of texture. So all of these things draw us to food. And hearing. Talking about Panera, talking about pizza, on the TV. Anybody watch the Super Bowl yesterday? Yeah, too bad Peyton Manning. But anyways, terrible woman I am. But every other commercial was what? Something about beer or something about food, right? The poor little M&M gets stuck in the trunk of the... That was pretty anticlimactic, I thought. Very bad commercial. But sight, hearing, cafeteria. They like to throw smells up into the atmosphere. One of the tricks we used to do when my kids were playing Little League, and we were trying to sell hot dogs at the snack shack. What did we do?
Use fans.
No, fry a bunch of onions, right? Because the smell just kind of permeated the whole area, and everybody's like, ooh, that smells good. I better go get a hot dog. So all of those things draw us to food. Hunger is a physiological sensation. But many of us in this country very rarely feel hungry. Have you ever really been hungry?
I'm like in between. You said, ones that like to eat. Depends on the days. Because I think the needs are like after dinner time. I think the kids are like, no, I better sit down again.
Yeah, because you're busy. Because life is hectic. Yeah. But do we really feel true hunger? Most of us never get to that point. We're very lucky. We have the ability to have 3 meals a day or however many meals a day we want. For the most part, there are people in our country that do feel true hunger. But that's going to help regulate your eating mechanism.
Isn't there a disease too where you never feel full even if your stomach is?
Yep.
Is that Willie Prater?
Hmm?
Willie Prater syndrome?
Is it Willie Pritter?
I think so. Something
Yeah.
like that.
But yes, there are.
I think that's a good signal. The person feels hungry.
Then they should go eat. But what do we do? What do we do in our country too? You have to eat breakfast, you have to eat lunch, and you eat dinner. And don't eat in between, right? So we kind of mess with that whole thing right from the get-go. We kind of don't listen to that anymore. The I'm hungry, I eat. That's when we should eat, when we're hungry. Not because the clock says 7 o'clock or the clock says 12 o'clock. It's when our regulating mechanisms say, go eat something, then go eat. What's the difference between hunger and appetite? Is there a difference?
Hunger is physiological drive.
Yep, that's like chemistry. But when I go to Olive Garden, I have an appetite. I might not necessarily have hunger. Do you see the difference? It's like, ooh, look at this menu. Ooh, dessert. Are we really hungry for dessert? No. No, we are not. Never are we, ever. But how many times do we get it? Because of appetite. See the difference?
My neighbor used to complain all the time because her son would make a sandwich before dinner, and he said, "Well, don't worry, I'll be hungry for dinner." It's like one thing if you're eating a little snack, but you would make like 2 sandwiches.
But see, he was probably hungry then.
Yeah,
And then he had to sit down and eat dinner.
yeah.
But that's when he wanted to eat. That's when he needed to eat, was when he made the sandwiches. Then maybe he shouldn't have had to sit down for dinner. Or sit down and not have to eat dinner. You see what I mean?
Or he was hungry, but he smelled the dinner cooking, and he wouldn't wait till the dinner was done.
Wouldn't wait till it was
5
done.
minutes.
He wanted it now. So when I feel full, And some of us ignore that signal too. It's called satiety, that feeling of fullness. It takes a while for our body physiologically to pick up those signals. So have you ever heard don't eat fast? How come? By the time your body physiologically figures out that you're full, you already ate way too much food. Anorexia. That's a physiologic need for food, yet no appetite. It's a control mechanism that people have. Hypothalamus. Now we're going to get a little scientific on us. What's a hypothalamus doing for me with respect to food? Yeah, that's the region of the brain, the feeding centers of the brain. So we have cells in the stomach, small intestine, that send messages and have a connection to portions of our brain. So as we eat, as we fill our stomachs and we have a stretch reflex, they speak to the hypothalamus. And hormones are going to help relay these messages. In anatomy and physiology, when we talk about the endocrine system and we talk about hormones, they work a little slower than a direct nerve impulse. So again, we have to give the body time to change, to allow these chemicals to make their way to the hypothalamus to get that message across. The hypothalamus is eventually going to be responsible for measuring the amount of consumed food and telling you, okay, you're done. So, nerve receptors in the stomach, stretch. Again, if I fill it really, really quick, by the time those stretch reflexes have started, the hypothalamus is going to get the message a little late. The other thing, blood glucose levels. It's going to take a while, though, for that glucose to get into our systems and trigger that signal. So we have different hormones. One's called insulin and one is called glucagon. And they are going to work together to help regulate blood glucose levels. Insulin, when I take in glucose, is going to help my cells use it. And glucagon I'm going to release when I don't do enough of taking in what I need to take in. So who didn't eat breakfast this morning? Too many hands went up. You feeling tired? Yeah. A little foggy? Yeah. Your blood glucose levels are going down. So you're going to die. No, you're not going to die because this hormone here, glucagon, will help go break down some of your stored glucose that you have in your body and release that into your circulatory system and hold you over. So what are you going to do when you leave class today? Go eat something. Get your brain going. Need some food. So midbrain regions, when we talk about physiology of the human body, anything that's kind of center in the middle of the brain is very well protected by all the other brain parts. Excuse me. And usually helping to regulate very basic functions like breathing or heart rate, or in this case, getting food into us. Food is a basic need. We need to get food into our bodies because we need to provide ourselves with building blocks and we need to be able to make energy to do the work we need to do. Another very important thing that food allows us to do is to produce these chemical messengers called hormones. So hormones are very specialized chemicals that are going to help trigger different cellular functions. Some hormones are actually going to stimulate us to be hungry. And some hormones are going to tell us we've had enough. And again, when we look at the digestive process and the digestive system, we talk about different hormones produced during that process that are going to help regulate food intake. We're not very good at regulating food intake as humans. We're just not. So, different effects food will have on us. Do you ever go to the Chinese restaurant and you eat tons and tons of food and you feel really full, and then an hour later you're hungry again? Yes? That one comes to mind, but some foods don't really hold us for very long with respect to satiety. Proteins tend to have a higher satiety value. So when we add protein to a meal, it tends to hold us, as far as hunger goes, a little bit longer. Why do you think? When I look at the different substances that I eat, and I'm talking about the calorie guys, proteins, carbohydrates, and lipids, fats. As far as breaking them down and using them, carbohydrates tend to have a lower satiety value because I'm going to break them apart and use them pretty quickly. Fats, it takes me a little bit longer, so they tend to have a little bit longer value. But proteins are very, very important for me. What do I want to do with the proteins that I eat? Excuse me. No, I don't want to use them for energy. I can. Yeah, I want to build things with them. They're big, huge, important building blocks. Proteins are made of amino acids, and we'll talk about that in this class as well. And those amino acids are the building blocks for our body, the structural stuff. So when I get a protein in, I'm going to work on it, break it apart, and build things with it. And that takes me longer to do and tends to hold my satiety value a little bit longer as well. So bulky foods tend to give us more of a sense of fullness because, what do you think we're doing? Yeah, you're filling your stomach, you're stretching your stomach. That stretch reflex sends a message to my hypothalamus, I'm full. So there's a whole bunch of different tricks, weight loss tricks. Has anybody ever heard the drink a big, huge glass of water before you sit down to a meal trick? Okay. Or when I create my plate, and you probably saw the My Plate under the My Pyramid in that same region in your textbook. When I create my plate, what should be the biggest part of my plate? The vegetables and fruits, right? Why? Yeah, bulk. That fiber adds bulk. So another weight loss trick, I'm going to have a big salad with my meal. So the proteins and the carbohydrates on my plate should be a lot smaller than the vegetable portion of my plate. And that's going to add bulk to the meal. Solid foods tend to be more filling than semi-solid foods. Anybody ever try the drink this shake diet? So you have 2 shakes a day, yummy, yummy shakes in this can that have been sitting on a shelf for 500 years, shakes, yum, yum. And then you have a sensible meal. What ends up happening with those diets? Yeah, exactly. You drink the yummy shakes, which aren't nearly as yummy as they advertise. And by the time you sit down for your sensible meal, if anybody puts their hands near your mouth, they're in trouble, right? Okay, so no, that doesn't work for us very well because that bulk makes us feel full. So you're much better having a sandwich or a meal that's maybe in the same calorie range as that supposedly yummy shake, and that's going to help you keep your weight a little bit better. So carbohydrates, proteins, fats, along with vitamins are also extremely important molecules that we need to bring into our body, those building blocks. What are we going to do? What's the goal of the digestive system? Why do you have a digestive system? Yep. Make big things small. Small enough to do what? Yep. Use at a cellular level. So think of your cells as factories. I have to provide your cells with the building blocks, the materials, the raw materials for it to do its work and its chemical work. So we're going to break very large molecules down into small molecules. So you aren't made of cheeseburger, but the cheeseburger parts are going to get broken apart and put back together in a different way to make you. Then the other extremely important job of the digestive system is to get all of those small molecules that you've now created and get them into where? Get them to your cells, but how am I going to get them to your cells? Yeah, circulatory system. So I have to be able to absorb them from the digestive system into the circulatory system and then transport them to where I need to do the work. So you might recognize this from your biology class. We go from small to big. The smallest building blocks are what we call atoms. Those are the smallest units of matter. Matter comes in 4 forms. We'll talk about 3. Solid, liquid, gas. So we're talking basic chemistry there. And then we take these little building blocks and bring them together to create molecules. Really, really important molecule for us, an example on the board, is H2O. What's H2O? Water. Why do we write it H2O? Well, we're going to take some atoms, oxygen and hydrogen, and put them together in certain patterns. 2 hydrogens and 1 oxygen makes a molecule water. And that molecule water is extremely important for chemistry in our body. So the organization of the human body starts at the very smallest building block, which is an atom. We bring things together and make molecules. Those molecules come together to make the smallest living units of our body, which is what? Cells. So if I take that same sentence, the smallest unit, and I add the word living to it, we now talk about cells. Cells come together to make different tissues. Tissues come together to make organs, and a whole bunch of different organs create the systems that we know of in our body. So molecules are extremely important. Chemistry is extremely important when we talk about nutrition. Anybody interested in becoming a nutritionist? You also better like chemistry. Did you know that? You're working on it? You're becoming more one with the chemistry? Because a nutritionist, and if you look at the curriculum you have to follow to become a nutritionist, you're going to have to take quite a few chemistry classes as well. I know. That's usually the one that scares everybody. But chemistry is the basis of what we talk about when we talk about nutrition. Cell's smallest living unit of life, and those molecules that we get from the digestive process are going to be used by those cells to do their work. Now, the reason why the food pyramid and a balanced diet is so important is because we need to get a variety of molecules in our bodies in order for us to create a functional cell, and then for that cell to undergo the chemistry it needs to go to be a functional cell. So when we talk about cells, the outer layer that wraps cells is called the cell membrane. And what's that made of? Yeah, phospholipids. What's a lipid? It's fats. So when we talk about a balanced diet, is it important for us to make sure we get lipids in our diet, fats in our diet? Most people who are having trouble with being overweight aren't overweight because of fat. Did you know that? Fat doesn't make most people fat. It's true. So eliminating fats from our diet is not a wise thing to do. We have to have a certain percentage of fats in our diet in order to get the building blocks we need to make every single cell in our body. Yes?
So when doctors are talking about, because I went to the doctor last week, and she kind of snuck in the whole do a low-fat diet, get exercise and everything in there, because my weight's right on their chart. And it's, are they saying that because they still believe that fat is making people fat, or they're just saying that because too much fat can make people?
Too much fat can give us too much calories. Too many calories can make us heavy. But if you look at most people's diets who tend to be on the heavy side, it's not usually because they have too much fat in their diet. Guess what they have too much of?
Carbs?
Yeah, carbohydrates. So lipids are important. And a lower fat diet, what does that mean, lower fat diet? How much? You're a scientist. We got to make sure that you know how much. What does that mean? What percentage of your calories should come from fat in a nice healthful diet? We saw it in the little chart in chapter 1. 25 to 35%. So if I'm thinking of a healthful diet, you probably want to shoot for the middle somewhere, right? About 30%. So in a day, 30% of your calories should come from fats. If you go way too low, and again, a lot of fad diets, well, no-fat diet. That was around for a while. I gained about 20 pounds on the no-fat diet. You ever eat Snackwell cookies? They're yummy. Yep. Too many Snackwell cookies. Guess what? You're going to gain weight. Did I have a lot of fat? No. Did I gain weight? Yes. See what I'm saying? So it's very important that you get your fats in your diet. Phosphate heads line the interior portion. Phospholipids. Lipids are what we call hydrophobic. So when we look at the phospholipid membrane, it's actually what we call a phospholipid bilayer. The phosphate end hangs out where the water is, and the lipid end hangs out in the middle. So if we look at the molecule, the phospholipid, kind of looks like a little lipid sandwich. So this is the phosphate end. The lipid end is in the center, and this is what covers the whole cell. The other very important building block for human cells, animal cells, is another very important lipid called cholesterol. Did she just say important? Did you hear her say that? I thought cholesterol was bad for me. Only what? If it's too much, right? Cholesterol is actually a very important building block. It's so important that your body makes it. You know who makes cholesterol? Your liver. So we can bring in the building blocks by eating other lipids. We don't really necessarily have to eat cholesterol. Sometimes when we eat too much cholesterol, I then have to deal with it, and that can be an issue. But cholesterol is extremely important building block of all our plasma membranes. And this plasma membrane, cell membrane, is something we call semi-permeable or selectively permeable. It's only going to let certain things in and out. So why do I have a cell membrane? So all the stuff doesn't spill out. Well, what's all the stuff? Inside cells we have liquid, we call cytoplasm, and then we have tiny little organs, little parts that are going to do the work, called organelles. So examples of organelles, when we look at them under the microscope in biology class, we see a big, huge nucleus. What's the nucleus doing for me? There's information in there. What kind of information? Yeah, your DNA. That's another organic molecule called a nucleic acid, DNA, RNA. That's kind of the directions for your cell. Other ones like the mitochondria. What's a mitochondria doing for me? Yeah, this is where I'm going to make a lot of the energy molecule, ATP, to help drive reactions of metabolism within the cell. So when we look at a cell, we see a bunch of parts or organelles wrapped up with this cell membrane. The cell membrane consists of those phospholipids, some cholesterol, and tons of different proteins. And proteins have a whole bunch of different jobs for the cell. Some of those proteins are going to allow things to come in and out of the cell. Some of those proteins are going to help regulate the function within the cell when they come in contact with hormones. And some of those proteins are going to act as what we call cellular markers. So other cells in your body know that those cells belong to you. So those proteins have tons of different functions for the cell. Cells then come together to form tissues. Example of a tissue would be this stuff that covers me. Do you know what this stuff is called? Well, my skin is actually an organ. It's made up of different types of tissue. The stuff we see on the outside is called epithelial tissue. Right underneath the skin, the dermal part of the skin, we have connective tissue. So skin is actually made up of two different kinds of tissue, epithelial tissue and connective tissue. So tissues are groups of cells that are similar, that are going to perform a different function for us. So what's muscle tissue doing for me? Yeah, it allows me to move from one place to another. What's nervous tissue do for me? Yeah, it's going to help control different body functions by sending electrical messages to different places. So skin again is an organ, and an organ is several different types of tissue that come together to perform a different function. So what's skin doing for me? Protecting me from what? Yeah, the outside. Yep, all the nasty stuff in the environment outside. So nothing spills out from the inside, right? It's going to help hold different organs in the body. It's also going to produce chemicals for us. Did you know skin produces chemicals for us? Yeah, one of the things skin's going to help us do is mature vitamin D. Vitamin D is going to help us with the absorption of calcium. So, other examples of organs, stomach. Stomach is a combination of a whole bunch of different types of tissue, a whole bunch epithelial, muscle tissue, connective tissue. Heart. What's the heart doing for me? Yeah. And again, combination of different tissues. On the inside of the heart, we have a nice smooth surface because when blood comes in from blood vessels into the heart, it bangs up against the side. Now, if the surface wasn't nice and smooth like this, what would happen to the cells when they came into the heart? They'd break. So the lining is very smooth and slick and slippery. Muscle tissue in between is going to create a squeezing action, and connective tissue holds everybody together, and that's the heart. Brain, same thing. Not only do I have neurons that are going to send electrical messages, but I have cells that are going to hold everybody in place there when we talk about the brain. Different organ systems are going to work to create different functions that are going to help maintain steady state within the body. Do you know what that ridiculous word is? homeostasis. So the gastrointestinal system is a bunch of different organs that are going to work together to take big things and make them small. So the food we eat undergoes 3 different processes once it comes in. It's going to be broken down from large to small, and that's what digestion is. Then we have to absorb it into the body and distribute it to all the cells. Then whatever is left that we can't use, what do we have to do? We've got to get rid of it, and that's what elimination is. So let's see if we can watch a couple of these things. Here's my...
Have you ever wondered what happens to the food you eat? To be utilized by the body, it must first be broken down into individual components, which are then absorbed into the blood. This process, called digestion, involves both mechanical and chemical transformations of the food and begins in the mouth. The transformation begins with chewing, a mechanical process also known as mastication, while the teeth cut and grind the food, increasing the surface area and exposing the bonds. The food is mixed with digestive juices from the salivary glands, called saliva. Saliva moistens the food and begins the chemical digestion of carbohydrates. While chewing continues, the epiglottis is open and the esophagus closed to allow you to breathe while you chew. When the food is soft and moist, it is time to swallow. As the food, now called a bolus, moves to the back of the mouth, the brain temporarily closes the epiglottis to prevent food from entering the trachea. The soft palate also rises to seal off our nasal passages, to prevent aspiration of food or liquid into the sinuses. As the trachea closes, the esophagus opens, allowing the bolus to be swallowed into the esophagus, to the stomach, by way of muscular contractions called peristalsis. As the bolus nears the end of the esophagus, a muscle called the gastroesophageal sphincter relaxes to allow the food into the stomach. This J-shaped organ has been waiting for its arrival by secreting gastric juices containing hydrochloric acid, HCl, and enzymes pepsin and gastric lipase, which chemically digest proteins and fats. The secretion of mucus protects the stomach lining from the acid and protein enzymes. In addition to the chemical breakdown of the nutrients, mechanical digestion continues by mixing and churning the bolus until it becomes a liquid called chyme and is ready to enter the duodenum. Once the chyme has been thoroughly mixed with the digestive juices, it passes through the pyloric sphincter and enters the duodenum. The presence of chyme in the duodenum stimulates 2 important accessory organs, the gallbladder and the pancreas, which assist but are not directly involved in the digestion process. As fat enters the duodenum, the gallbladder contracts, secreting a greenish fluid called bile, which emulsifies the fat, breaking it into smaller particles. The pancreas secretes enzymes specifically designed to digest carbohydrates, proteins, and fats found in the chyme. Further chemical digestion aided by enzymes located on the small intestine complete the process of digestion. The sandwich you ate has now been processed into a liquid that contains nutrient molecules small enough to be absorbed. As the chyme moves along the small intestine via peristalsis, the nutrients encounter absorptive cells in the intestinal lining. The specialized lining is composed of thousands of finger-like projections called villi. The cells covering the villi end in hair-like structures called microvilli that together form the brush border and increase the surface area. Nutrients enter the body by passing through the cells of the brush border and then flow through the capillaries or the lymph fluid to the cells in the body. Undigested or unabsorbed nutrients and other compounds from the sandwich you ate enter the large intestine through the ileocecal valve. As the waste material enters the cecum, they mix with intestinal bacteria, which digest any remaining particles. As chyme travels through the colon, water and other chemicals are absorbed, forming a semi-solid mass called feces that is eventually eliminated through the rectum, the ultimate fate of the sandwich.
The ultimate fate of the sandwich. Interesting. Oops. Yeah. All right, so don't panic. We'll go over all of these steps, so you didn't have to get it all from that little movie. So, why isn't this? There we go.
After eating a meal, the body is challenged to absorb the molecules that have been digested in the food. This challenge is met mostly by the small intestine. The villi, microvilli, and tubular glands called the crypts provide a large surface area through which our bodies absorb nutrients. There are 3 different processes involved in nutrient absorption: simple diffusion, facilitated diffusion, and active transport. The first absorption process is referred to as simple diffusion, when molecules move from areas of high concentration to areas of lower concentration. This does not require any assistance because water and small lipids can pass back and forth freely through cell membranes. Another form of absorption is known as facilitated diffusion. This process requires a specific carrier molecule to help certain nutrients across the cell membrane. Water-soluble molecules, such as vitamins, are examples of nutrients that utilize this form of absorption. The third form of absorption is active transport. This process requires energy in addition to specific carrier molecules. The combination of energy and a carrier promotes absorption against a concentration gradient, as is the case with glucose and amino acids.
So, getting food small enough so that I can use it, and then using it is a process, yes? In the digestive system, the gastrointestinal tract, or our digestive tract, is a series of long organs, tubes, with accessory organs that add chemicals to the process that are going to help us make systematically smaller molecules for absorption. So when we talk about enzymes, and we talk about the stomach, and we talk about the small intestine, and all the little parts of the small intestine that are going to help with the process, it's basically part of the tube that's going to make large things small. So the gastrointestinal tract is going to include the tube. And the tube gets looking different as we go from the beginning to end. In the beginning, the tube is the esophagus. It's a nice straight shot down from the mouth to the stomach. It's muscular, so when I swallow, food just doesn't go from my mouth into my stomach, does it? No. Sometimes we feel like it does that, but it doesn't. It gets pushed down that tube by muscular contractions called peristalsis. And then the tube gets a little bit wider, and that's the stomach. We're going to see different cells lining the tube at that point to make different chemicals to help break down our food. The other thing the stomach does is churn the food, mixes all the chemicals with it. Sometimes when your stomach growls, you feel it doing that, right? But it mostly does it after you've eaten, because you're churning the food, mixing it with the chemicals to help break it down. The other very important part about the digestive process is to keep food in different portions of the tube for certain periods of time. So we have little trap door muscles that close off the tube so things will stay put for a while. Those little trap doors in the tube are called sphincter muscles. So they mentioned one coming from the esophagus to the stomach in that little movie, the gastroesophageal sphincter muscle. So when I swallow, eventually I'm going to close off that little sphincter muscle once I get food into the stomach. Now, some of us have problems with that little sphincter muscle. Anybody have a hiatal hernia or suffer from reflux? What happens? Yeah, that little sphincter muscle doesn't keep food where it should be down in the stomach. And what happens? It comes back up into the esophagus. Now, down in the stomach, we have a very hostile environment. And what do I have down there in the stomach that I produce to help me break down food? Yeah, hydrochloric acid. Did you ever put hydrochloric acid on anything? What does it do? It burns it. It dissolves it. It breaks it down. That's what it's doing to your food, breaking it down. But was it meant to be on the esophagus? No. What do we call that sometimes? Heartburn, because we get a burning sensation when the acids wash up on the esophagus.
What is or is there a difference between acid reflux and heartburn?
No. Yeah. Acid reflux causes heartburn. Heartburn is just a layman's term of describing it. Now, it could be, you don't necessarily suffer from gastroesophageal reflux disease if you get heartburn. Sometimes you get heartburn because too many spices or too much food in our stomach might cause it to wash up on the esophagus. So there might be the difference there. So those sphincter muscles are very important. We find them scattered throughout the digestive system. And they're going to help hold things in place so they can be worked on chemically by that particular portion of the tube. Once we pass from the stomach, we go into a smaller 21-foot section. So if I was standing right about here and I took my intestines out, I could probably hit the overhead projector over there. So about 21 feet of smaller tube is where the small intestine is going to continue to break things down. And a lot of what happens in the small intestine now? The absorption. So when we look at the small intestine, we see a very highly vascular tube where absorption takes place. Then we go on to the large intestine, where most of my absorption is taking place, but I can still break a few things down and still get a little bit more out. There's wonderful bacteria in your large intestine. We call it your normal flora. Have anybody heard of, and they're talked about a lot more these days, probiotics? There's a couple of products on the market, yogurts, yeah, that have high levels of good bacteria in them. Did you have a question? No. Those bacteria are actually helpful in the digestive process. In the lower part of the process in the large intestine, some of those normal bacteria can pull out a couple of really important things like very essential vitamins for us that we normally couldn't do on our own. With the help of them, we can pull them out. B vitamins, for example. Bacteria are very highly helpful in extracting those from the food that we eat. And then what happens to everything else that's left? Yeah, we get rid of it. Elimination, defecation. So, purpose, break large foods into small. 2 ways, mechanical, actually squishing it. Where does mechanical digestion most obviously take place? In the mouth when we chew up our food. It also takes place in the stomach. The stomach muscles are constantly churning and adding chemicals. So this is where we begin. We actually begin it in the mouth, believe it or not, because what else do we do to our food before we swallow it? We spit all over it. Yes? What's our saliva doing for us? Yeah, moistening it so that we can break it smaller mechanically. But there's also enzymes or chemicals in our saliva that are going to help break down substances as well. So mechanical digestion and chemical digestion play a big role in the digestive process. My slow computer today. No, I'm going to skip this one. Sorry. So, digestion actually begins in the mouth. Chewing is a part of the digestive process. And not only is chewing part of the mechanical digestive process, but the action of chewing is actually going to send messages to the rest of the tube. So when we talk about digestion, we talk about that big long tube. And messages, chemical messages, are sent to parts of the tube to start producing their chemicals during the digestive process. So chewing your food serves the purpose of making it smaller. But adding saliva is going to actually begin the chemical digestion process as well. There's a couple of enzymes. The one that has the best action is an enzyme called amylase. And amylase has the job of breaking apart carbohydrates. Carbohydrates are sugars. We can have simple sugars and we can have complex sugars. An example of a complex carbohydrate, anybody? Starches, potatoes, whole grains. They, when broken down into their small building blocks, are basically sugars or carbohydrates. And amylase is going to start that process right in the mouth. It doesn't work very long because once it hits the acid bath of the stomach, it neutralizes it. We're going to pick up with carbohydrate digestion a little bit later on down the tube, but we start it right in the mouth. There's also lipase secreted in your saliva as well. And lipase, guess what it breaks down? Lipids. Again, it doesn't work very long, works for a very short period of time, gets neutralized. We're going to pick up by adding more chemicals later on in the digestive process. The epiglottis, very important little trap door, because we have two tubes in our neck, the one in the front and the one in the back. The one in the back is the one we're concerned with respect to the digestive process. What does the one in the front do? That one carries air to the respiratory system. Now, I don't want food going down that tube, do I? What happens when food tries to go down that tube? We choke and do what? We force air in the opposite direction because food should not go down there. And this little trap door called the epiglottis is going to close that shut when we swallow. So when we swallow, there's a little muscular action that goes on. It's going to actually help close the epiglottis. It's going to cover the opening of the trachea and prevent you from swallowing your cheeseburger in your lungs. Yes? It shoots it down the back tube when it closes off the front tube. The back tube is what? That's your esophagus, exactly. So food's going to travel from your mouth via the esophagus to your stomach. And again, little muscular contractions of that tube are going to push that food down. Do you ever swallow something a little bit too big? And you feel it going on.
You know it takes a long time to get
Exactly. You're going to kind of get stuck right around in the mid-chest region. And you know, oh, I better slow down a little bit, chew my food. That's peristalsis, and you can actually feel it trying to push that food down. So in the mouth, we chew our food, begin mechanical digestion. We start chemical digestion with amylase, breaking down carbohydrates. Not too much digestion takes place in the mouth. We're just beginning the process. Is chewing important, though? Extremely important. When I swallow, that soft palate rises. That's going to close off my nasal passages. Have you ever started laughing with something in your liquid in your mouth and have it come up your nose? It's bad when it's soda, right? Whoo, those bubbles hurt. Milk up the nose, yes? So they're connected. When we talk respiratory system and digestive system, we share these common passages here. So if I get all stuffy and I can't breathe through my nose, what can I do? Breathe through your mouth. So the epiglottis is very important. When I swallow, it's going to act as a trapdoor to shut off that front tube, the trachea, so that food goes down the back tube, the esophagus. Again, peristalsis is going to bring food from the mouth to the stomach. No digestion is going to happen in the esophagus. If we look at the cells that line the esophagus, they're very, very thick and protective. They're very similar to these cells that protect you on the outside. Nothing can really penetrate those groups of cells. So basically, the esophagus is a transport tube from the mouth to the stomach.
It's kind of random, but like when people get a tube to help breathe, is it automated in your trachea or like automatically open so it goes in?
Correct. So we slide it in and stick it right into the trachea. Sometimes it is here, sometimes it actually goes down in. But it keeps it open so you can breathe. So the first sphincter muscle we're going to be introduced to with respect to the digestive process is the gastroesophageal sphincter muscle. And that's going to separate the esophagus from the stomach. Again, we want everything to go in one direction when we start and when we finish. We don't want anything back up in the opposite direction. Everything should move one way, and the sphincter muscles are helping that to happen. So it's going to prevent flow of food from the stomach back up into the esophagus. That's important because the chemicals, when you chew, that are produced in your stomach to continue the digestive process are very caustic. In the stomach, we're going to continue the mechanical digestion because muscles are going to continue to sort of mix that food with the chemicals that are produced in the stomach. And the chemicals that are produced in the stomach are chiefly going to start breaking down proteins and a little bit of our fats. But the biggest digestion that we do in the stomach, protein digestion. One of the important components of protein digestion is having an acidic environment. So we have cells that line the insides of our stomach that actually produce hydrochloric acid. That hydrochloric acid is going to activate another chemical produced by the lining of the stomach called pepsin. So the two are going to work together to break down proteins. We also produce a little bit of something called gastric lipase, and that's going to very, very little break down some fats there as well. The other thing we produce is a protective lining inside the stomach. The reason we need to protect those cells is because if we don't protect those cells, what are the chemicals going to do to them? Break them down. So we also, in the lining of the stomach, produce mucus. And mucus acts as a protection for the cells that produce all of these chemicals. Kind of like, have you ever gotten really dry skin and you put either skin moisturizer or Vaseline? Have you ever used Vaseline to protect your skin? That's sort of what the mucus does inside the stomach lining. It protects the lining. It protects those cells so that the chemicals don't actually break down your stomach. Now, what happens if you have a breakdown in cell production and you produce too much acid and not enough mucus?
Ulcers.
Yeah, that's what an ulcer is. Does anybody ever suffer from an ulcer or know somebody that suffers from ulcers? So several different things can break down. Mechanisms, signaling mechanisms from the nervous system can break down so that you don't produce enough mucus. Sometimes stress can cause us to decrease mucus production. And that will cause the chemicals to break down the stomach lining and actually form a hole there. An ulcer in its really bad state will then allow what to happen? Things to leak out of the digestive system, which is not good. We don't want hydrochloric acid floating around in the rest of our body, do we? No. So when we take these chemicals produced by the stomach, and collectively we call them gastric juices, and mix them together with the food and the spit that we swallowed, we create a substance called what? Chyme. And chyme is kind of a semi-solid mixture of food and chemicals. Again, when we look at the stomach, we see a series of muscles in a whole bunch of different directions that can cause a squeezing effect. And we have sphincter muscles on either end to make sure things stay in the stomach while this process goes on. We already met the gastroesophageal sphincter muscle, and then we have another one on the other end that's going to wait until everything gets mixed before it dumps things off into the small intestine, called the pyloric sphincter muscle. So what we see going on in the stomach, a bunch of churning, mixing, taking that gastric juice secreted by the lining of the stomach, mixing it with our food, activating some chemicals like pepsin, gastric lipase, small amounts of water, some minerals, drugs, and alcohol are actually absorbed from this point. Yes?
I thought I worked at CMC, and there are a ton of patients that have what's called H. pylori, and it's like very crunchy, and they have Hashimoto's.
Yeah.
What exactly is it? I know it has to do with the digestive system, but is it bacteria?
Yep. It's a bacteria that lives in the lining of your stomach, and it can cause you to produce an excessive amount of acid and a decreased amount of mucus. So when we look at patients, and this is fairly new to the scene, because we always thought nothing could ever live in the hydrochloric acid bath known as our stomach. And then we discovered, oh yeah, we were wrong, H. pylori lives there. So this bacteria, it tends to be found in patients with ulcers. So there's a link between the bacteria and the bacterial action and the formation of ulcers in patients. So we ingest it somehow from our environment, and then it can affect us in different ways. In some patients, it can result in ulcer formation. So, some absorption in the stomach, not a whole heck of a lot. Where's most of the absorption going to take place? Small intestine. So once we get to a certain consistency, once the pH reaches a certain point, that's the chemical message to open the next trap door. So you see what I mean? There's tons of chemical messages signaling the tube later on down the line. Once chyme reaches a certain consistency in pH, it's going to act to open the trapdoor. The next trapdoor in line is the pyloric sphincter muscle. And that's going to allow that mixture of chemicals and food to enter into the small intestine. Now, the small intestine isn't crazy about the pH. So some of the secretions that are going to be added to the small intestine are actually going to help neutralize the pH of that chyme as it comes from the stomach and goes into the small intestine. Again, when mechanisms break down, chemical mechanisms break down a little bit in certain people, this is where the problem areas tend to be with respect to forming ulcers. So the beginning of the small intestine might be a very common place for someone to form an ulcer. So, there's a bunch of different organs that are going to help this tube do its thing. These guys are called accessory organs. So the salivary glands are not actually part of the digestive system. We call them accessory organs to the digestive system. The digestive system is a big tube, right? Starts here, ends there. But all of these guys are going to add things to the digestive process. The liver produces a substance called bile. The pancreas is going to produce a whole bunch of different substances to help with the chemical digestion. And the bile that's made in the liver is kind of a little bit on the watery side. So we also have another structure associated with the digestive system called the gallbladder. Bile is produced in the liver, and it's sent to the gallbladder where it's actually concentrated. So here's an analogy for you. In the old days when I used to go to Sam's Club and buy my laundry detergent and my diapers, yes, it would come in this big, honking, huge, gigantic bottle of liquid laundry detergent. How much laundry detergent did I have to put in the washing machine? About a cup, right? You had to put a big honking cup in there. That's not how it works nowadays. What do we have? We have much smaller bottles. And how much soap do we have to put in the laundry now? Just a tiny little capful, right? Or those little pods. Yeah, I use those. Did the soap change? Soap's the same. Soap is soap, right? What changed? The concentration. Instead of putting lots of water with our soap in these big, huge jugs, somebody got the bright idea that if we suck all that water out, then we only have to put this much soap. You see where I'm going? That's what the gallbladder does for us. So it takes that watery bile that the liver makes, sucks out the water and concentrates it. So the same job gets done with a very little amount with the help of the gallbladder. So a gallbladder is going to store bile for us, and it's going to concentrate bile. Yep.
So what if you get it taken out?
Can you still digest fats? And that's what bile is going to help us with. Yes.
So then what's the point if we don't really need it?
Yeah, but now remember the laundry detergent. I'm only going to get a little squirt now. Are my clothes going to get so clean? No, because my laundry detergent is very watery. Are my lipids going to get digested as efficiently without my gallbladder to concentrate? No. So you're still going to be able to, and we'll talk when we start class on Wednesday what bile actually does. You're still going to be able to break down your lipids, but not as efficiently as you could when you had your gallbladder. So what are you going to have to be careful of when the gallbladder's gone? Yeah, Kentucky Fried Chicken is no longer on the list of restaurants in which you can go and have fun. Because what's going to happen? When you eat large amount of lipids in a meal, you're going to not be able to break a lot of them down. And when you don't break a lot of them down, they pass through the digestive system and cause a lot of hate and discontent, like gas and bloating. Because normally, when you had your gallbladder, you would be able to break them apart more efficiently. So one without a gallbladder has to be careful of high-fat meals. Ice cream is my favorite food in the whole wide world. And we're no longer friends because I don't have a gallbladder anymore. It's sad. I'll leave you on that sad note. Make sure, did everybody sign the sign-in sheet? If you didn't, please do. And I will see you on Wednesday. We didn't finish the chapter, so don't worry. We'll finish the chapter Wednesday, and I'll open up the quiz.